10 real data engineer interview questions from a Quest2Offer mock interview. Pause on each one, think how you'd answer, then I'll show you how. Question 1. Batch versus stream processing. What's the difference and when do you use each? Batch processes data in chunks on a schedule, high throughput but higher latency. Streaming processes each event as it arrives, low latency and continuous, but it needs windowing and state. Use batch for reports and ETL where minutes are fine. Use streaming for real-time like fraud or live dashboards. Many teams run both, streaming for freshness, batch for correctness and backfill. Question 2. Why is Parquet so much faster and cheaper than CSV for analytics? Parquet is columnar. It reads only the columns your query touches, which is a huge I/O saving. You also get great compression because similar values sit together, plus predicate pushdown and column pruning. Row formats like CSV are fine for ingestion or small data, but slow and bloated for analytics. That's why Parquet is the default for data lakes, Spark, and modern warehouses. Question 3. What's a star schema and why model data dimensionally? A star schema has a central fact table, the events and measures, surrounded by dimension tables, who, what, when, and where, joined by keys. It's denormalized for fast, simple analytical queries, unlike a normalized OLTP database. Star puts dimensions directly on the fact. Snowflake normalizes them further. The key decision is the grain, what one row means, and conformed dimensions let you join across facts. Question 4. How does a distributed file system like HDFS handle replication and fault tolerance? Files are split into blocks, say 128 megabytes, and each block is replicated across several nodes, 3 by default. The name node tracks the metadata and where every block lives. The data nodes store blocks and send heartbeats. When a node dies, the name node re-replicates its blocks elsewhere to restore the replication factor. And rack awareness spreads replicas across racks, so you survive losing a whole rack. Question 5. Designing for high throughput and low latency. What are the trade-offs? They pull against each other. Batching and buffering boost throughput but add latency. Tiny batches cut latency but lower throughput. Your dials are micro-batching, partitioning and parallelism, backpressure, and async I/O. Find the real bottleneck, I/O, CPU, or network, and scale that while avoiding shuffles and data skew. Often you accept good enough latency for throughput or split a hot path from a cold path. Quick pause. These questions come from Quest2Offer's AI mock interview, technical or FAAng format. The AI asks questions for your exact role, you answer in writing, and you get a breakdown of your weak spots. Try it free at Quest2Offer.ai, then back to the questions. Question 6. What is idempotency, and why is exactly one so hard? Exactly once is genuinely hard in distributed systems, so most pipelines do at least once delivery, plus idempotent writes, which gives you effectively once. Idempotent means reprocessing the same event doesn't change the result. Think upserts by key, or dedup on a unique ID. Use transactional sinks. Idempotent produces in Kafka and checkpoint your offsets so a retry never double counts. Without it, retries silently double your data. Question 7. A Kafka consumer group falls behind by hours. What do you check? Lag tells you how far behind the latest offset you are, and growing lag means you can't keep up. First ask, is the consumer slow because processing is heavy, or are there too few partitions to parallelize? Scale consumers up to the partition count and profile the handler. Then watch for stuck consumers, long garbage collection, a blocking call, poison messages, or a downstream bottleneck holding everything up. Question 8. How do you handle schema drift in a source system? Schema drift is when a source field gets added, renamed, dropped, or retyped, and it silently breaks or corrupts everything downstream. Defend with a schema registry and compatibility rules, backward and forward, plus real data contracts. Handle it gracefully. Make new fields nullable, cast explicitly, quarantine bad rows, and alert on drift. Validate on ingest with expectations. Never blindly trust the source. Question 9. Data lake versus warehouse versus lakehouse. How do you choose? A lake is cheap object storage holding any raw format, schema on read, flexible but it can become a swamp. A warehouse is structured, schema on write, with fast SQL for BI, pricier and less flexible. A lakehouse puts a table format like Delta or Iceberg on the lake, giving you ACID schema and time travel at lake cost. Choose by use, lake for raw and ML, warehouse for BI, lakehouse to get both. Question 10. What does an orchestrator like Airflow give you over cron? An orchestrator runs your pipeline as a DAG, a graph of steps with dependencies, scheduling, retrees, backfills, and alerting. Tools like Airflow, Dagster, or Prefect let you declare tasks with their dependencies, and the scheduler handles order and failures. You get idempotent reruns, observability, and SLAs instead of a fragile chain of cron jobs. Just keep every task idempotent and atomic so retries and backfills stay safe. That's all 10. How many did you get? Tell me in the comments, then like, subscribe, and try a real mock interview at Quest2Offer.ai. Good luck on your next one.